A shipment has 15 computers, 2 of which are broken. 3 of these computers are chosen at random to test. Give the probability distribution of the number of broken computers that are sampled. Okay, let's see. We need a probability distribution. In order to set up this probability distribution, I need to decide on a random variable, and x, in this case, if I'm counting something, it would make sense to count the number of computers that are broken. Especially since we give the probability distribution of the number of computers that are broken. So that are sampled, that are broken. So x is going to be the number of broken computers sampled. The number of broken computers that are sampled, I could choose 0. There's 15 computers and only 2 of them are broken. I'm sampling 3. So the possible numbers of broken computers could be 0, 1, or 2. It couldn't be 3 broken computers since only 2 of them are broken. So I'm setting up my probability distribution. That's my different values of my random variable up here. Now I need to figure out what's the probability of being in each of these with a probability distribution, this is the entire sample space. So I do know one thing I can do at the end if I wanted to check to make sure I'm making no errors. If I was to add these up, it would sum to 1. So I could double check that at the end, but we'll get there. First off, I'm going to figure out what is the probability of getting 0 broken computers. Well, you might want to say that this is a binomial distribution at first, but if the first computer you draw is a broken computer, it will change the probabilities that the second computer you draw is broken. And so these are not independent. Instead, what we need to do is we need to approach this from a counting standpoint. I need to say n of e out of n of s. So the number of ways that I can get 0 broken computers divided by the number of ways that I could get just my sample. So let's see, there are 2 broken computers, and I'm choosing 0 of them. I'm using combinations here because I'm just taking samples. I'm not ordering them. Let's see, there's 13 non-broken computers that I need to draw 3 from. And my denominator here is, well, 15 computers, I'm drawing 3. So this will be 2 choose 0, 13 choose 3, over 15 choose 3. And I'm intentionally leaving it written like this because these other ones are going to be pretty much the same format. The probability I get 1 broken computer, well, from the 2 broken computers, I'm choosing 1. From the 13 good computers, I'm choosing 2. And from the 15 total computers, I'm choosing 3. So I get that, and then here I get 2 choose 2, 13 choose 1, over 15 choose 3. The same pattern we saw in the previous sections is happening again. The top parts add up to 15, the bottom parts add up to 3 on all of these. And I should probably actually figure out, I should have left a little bit more room here, shouldn't I have? That way I could say what these numbers are. I'm going to write them down here. Well, actually I'm okay with them written like that. I'm just going to leave it like that. Find the expected number of broken computers. To find the expected number of broken computers, this is not binomial, so I don't have any shortcuts. I need to just walk through my expected formula. 0 times the probability of 0 broken computers plus 1 times the probability of 1 broken computer plus 2 times the probability of 2 broken computers. You'll notice I'm multiplying this thing by 0, so I can just ignore that first one. I'm multiplying this one by 1, so I'm just going to go ahead and say this is 2 choose 1, 13 choose 2, over 15 choose 3. I'm going to leave everything at over 15 choose 3. Just kind of put that denominator under everything to make my simplification a little bit easier. And then for this number, I get 2 times the probability of 2. This is 1. So, and this is 13. So 2 times 13. The only number, and this one right here is 2. So there's actually only 2 combinations here I don't know the values of. 13 choose 2 and 15 choose 3. Those are the ones I'm going to have to plug into my calculator. So we get 2 times 13 choose 2 plus 26. That's the 2 times 13 right here. So the numerator of this fraction is 182. The denominator is 15 choose 3 which gives us 455. 182 divided by 455. This is an average, so it does make sense to have a decimal here. On average, we would expect to get 0.4 computers. And again, don't let the fact that it's not possible to get 0.4 broken computers bother you. This is an average. So some of the times, a lot of the times, you're going to get 0 broken computers. Sometimes you're going to get 1 broken computer. Sometimes you're going to get 2 broken computers. And if you take and average all those together, you will end up getting 0.4 broken computers on average.